Hello everyone, my name is Suresh Prakash and today I am going to give you the idea about how electronic converters, principles, types and application. I am an assistant professor in electrical engineering department at Government College Jahanabad. After watching this video, you will be able to learn following things like define and classify the main types of power electronics converters such as AC to DC, DC to DC, DC to AC and AC to AC. There are different types of converters. And based on the input and output waveforms and their fundamental principles, you can classify them. And the second outcome will be you will be able to explain the operation of the AC to DC rectifiers, including the current control and the controlled one, along with the configuration. And you will be also be able to calculate the key parameters such as average output voltage and ripple factors. Along with these, some other learning outcomes are like you will be able to describe DC to AC inverters and also distinguish between this voltage source and current source types. Along with that, you will also come to know that what is the pulse width modulation techniques and how it is useful in reducing the mm, total harmonics in the output of the AC. And you will also get this idea about this DC to DC chopper circuit, which are of three types like buck boost and buck boost. And you will be able to derive the voltage gain equation, duty cycle, and identify the suitable application like voltage regulation for this. Other learning outcomes will be like you will be able to come to know that the real world application of these converters where it will be used, like it will be used in renewable energy, electric vehicles, and other consumer electronics, like you are using charger. There you will also find that there is some converter or electronic converter is using there. And you will also be able to evaluate the emerging trends like earlier power electronic converters were based on silicon or germanium, but now these are based on this silicon carbide and gallium nitride, which are pushing the boundaries further for electronic converters. So this is about this introduction to power electronic converters. So in introduction, you will be come to know that the power electronic converters are used to transform electrical power from one form to other form, like AC to DC, but with higher efficiency. You can also you have also seen that in some other electrical equipments that there is going transformation is going on, but there is efficiency issues there. But here you will achieve greater than 90% efficiency. Even you can go to 98%, 99% efficiency. So the key role is to enable renewable energy, EVs, and industrial drives by controlling voltage, frequency, and control. Basic block diagrams like how a converter is working. There will be an input source and some switches and some filters to get the more refined output. If you are getting AC to DC converter, then DC will have some ripples, and if you are getting DC to AC converter, then AC will have some harmonics. So for that, you are using filters, and then you will connect this to an output loop. For evaluating the efficiency, there is a formula, general formula that output power by input power into 100, where output power is P is equal to V into I, depending upon which type of voltage you are getting in the output. If we will go to see the types of power electronic converters, then there are four types of power electronics converter that we are going to learn. But out of these three, we have to study here. So first one is the AC to DC rectifiers, that is used to convert the AC to DC, and these are used in battery chargers and the PSUs. Other one is DC to DC choppers, that is used to step down or up the voltage. These converters are used in laptop adapters, LEDs. Some other are like the DC to AC inverters, that is used to convert DC to AC, and these are used in solar inverters, UPS. AC to AC inverters AC to AC converters are also used, like direct AC, if we have to control direct AC frequency or voltage, and these are used in motor speed control. You can also see that in this diagram. that some persons are installing this solar panel there. So these solar panel also required some power converter so that we can use this converted solar power to electrical power. Yes. So going to this AC to DC converter, in AC to DC converter, there are two types of converters. First one is the uncontrolled one, that one is diode based, and the second one is the controlled one, which one is the that one is the thyristor based. In diode based, you don't get the control on the output voltage. Just you set the topology of the diode and apply some AC voltage on the input side, and you will get an output voltage on the DC side. And this the average output voltage you can determine by the given equation VDC equal to 2 Vm by pi for a full wave, and that will be equivalent to zero point 0.9 volt of VRMS, zero point 0.9 into VRMS. Whereas in controlled rectifier that is using thyristor, the average output voltage is given by VDC is equal to 2 Vm by pi cos alpha. And here you will get the control on the output voltage. Control means you are getting the desired output voltage. If you want to change the output voltage for different values for the same AC voltage applied, then you can change it by controlling this alpha called firing angle. Some of the applications of the AC to DC converters are power supplies and building equipment. Ripple factor for single phase full wave rectifier is around 4.48. But if you want to reduce this ripple, then you can go for the three phase rectifiers. And a simple video you can see here in that how a single phase full bridge rectifier is working. So after watching this, we will go to DC to DC converters. So DC to DC converters are of three types. First one is buck, second one is boost, and third one is the buck boost. Buck is used to step down the applied input voltage. DC to DC converters actually convert a fixed DC voltage to the variable output DC voltage. And if this variable output DC voltage is less than the applied voltage, then it will be called buck or step down converter. If it is greater than the output voltage, then it is called boost or step up converter. But if it can be used for both a step up and a step down, then it will be called the buck boost converter. The formula for all the following are given. Like for buck, you will get V output equal to D into V, where D is the duty cycle. Duty cycle means this you can see that all these three converters are shown in this image, and there are always a switch. There is always a switch there. So for what time this switch will be on, that will define the duty cycle. Duty cycle is defined like D is equal to T on by T, means total on time by time period of the duty cycle and time period of the cycle. So in this way, you can get the output voltage of buck V output is equal to D into V, output voltage for boost V output is equal to V input by 1 minus D, and output voltage of buck boost converter is equal to D into V input by 1 minus D. These converter can work on continuous conduction mode and discontinuous conduction mode, but here we have considered that these are working on continuous conduction mode. Next one is the DC to AC converter. In DC to AC converter, the voltage source inverter, uh, it is a voltage source inverter, and the voltage source inverter is used to convert this fixed DC input to variable AC output. And that you can see that the in the diagram, a single phase H bridge with four switches is shown in this diagram that is used to run a motor. So what is happening that we are supplying a DC voltage here, and the output is the AC, and this AC supply is used to run this motor. Current source inverter is also there, in which the current will always be constant and it is used for inductively. Some modulation technique like PWM for sine wave approximation is used, that is used to reduce the harmonics. And the output of the output will be fundamental frequency F output independent of switching frequency SW. Means the switching frequency, whatever we apply, it will not affect the fundamental output frequency of the converter. For its application, you can go to the given link here. Next is the application and example. You will find the power converter application in renewable energy, electric vehicles, consumer electronics. Everywhere today, there is the power electronic converter. Like we have already discussed, that you can see in this image that a charging station is there in which a solar panel is used to charge the car. So here, what is we are seeing that the power electronic converter is used in electric vehicles and in solar panel and in other chargers also, where like in AC to DC in basic chargers and DC to DC in laptops. So there are multiple applications, and everywhere in our life we can say that the power electronic converters are being used. Advantages, challenges, and future trends of this power electronics converters are like advantages are high efficiency, compact size, precise control, and also it makes us to use the renewable sources very comfortably. And the challenges we face, still we are facing some challenge like harmonic distortions, EMI, mitigated by filters or PWM. And there is also a high cost for wide bandgap devices. Current trends is like AI optimized control integration in smart grids. So coming to conclusion, can see that the converters are pivotal role for modern power system, and we have to understand the types and application specific design, like what type we are going to use for which purpose. So according to that, we have to decide the converter, that which converter we should use for data specific purpose. And we should go for some new experiment with simulation tools like LTS Spice to explore more for new power electronics. These are the references. Thank you.